Number lines are very important in math, and they can help us solve some ratio problems. So what we're going to do is we're going to look at two ratio problems and see how the strategy of using a double number line can help us solve. So let's see what we have here. A produce store sold 45 red apples. If the ratio of red apples to green apples sold was 5 to 2, how many green apples were sold? Okay, so let's highlight the important information here. A produce store sold 45 red apples. That's important. And the ratio of red apples to green apples was 5 to 2. Okay. And what do they want to know? They want to know how many green apples were sold. So we're going to go back to our ratio basics, our questions. And first we're going to ask, what are we comparing? And we're comparing red apples to green apples. What is the ratio? The ratio is 5 to 2. That extra piece of information is that they sold 45 red. And what we want to know is how many green apples did they sell. In order to start, I'm going to label, because I always label. I'm going to label my number lines red and green. And let's draw two number lines, because it is a double number line. And because this is a problem about apples and you can't have negative apples, we're going to start each number line with 0. And you can see we're kind of connecting them because they are a double number line. Now I'm going to make my intervals. And when you make your intervals, just like when you make a fraction model, you kind of try to get them as evenly spaced as you can. And okay. And you want to make sure your number line is long enough, and sometimes I make this mistake, to fit all of your apples. So let's see. If you look back at our ratio, the part that stands for the red is 5. And so what we want to do is we want to, on our red number line, the top one, we want to count by 5s, because remember, ratios are all about repeating the original pattern. So we're going to count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45. And I can stop now because of the 45 red apples in the problem. I know that I don't have to go past 45. Now, again, repeating the pattern, if you look at the green, we're going to count by 2s because the green part of the ratio is 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And you see that 18, I'm going to stop because it matches up with 45. So, how do I get my answer? Well, since the store sold 45 red apples, I'm going to circle 45 on my number line. And what number goes with it? What number is attached to it? 18. And so the answer to the problem is that when they sold 45 red apples, they sold 18 green apples. Now, the whole basis, again, for this is that we're repeating the pattern. And what we're using here is additive reasoning, because you will see between every interval, we're adding 5 red, because that's the red part of the original pattern. And for the green, we're adding 2 because that is the green portion of the ratio. And We are adding according to the ratio. So if you kind of know about ratio tables and additive reasoning, this works on the same premise as using additive reasoning on a ratio table. But it's kind of fun, and I think it's easy to use. So let's take another problem and see if we can do the same strategy. A chess player won 72 games. Let's get ready to highlight. A chess player won 72 of the games he played. If his ratio of wins to losses was 9-4, how many games did he play total? This is an interesting problem. It's a little bit different. And so let's see, what's important in the problem? Well, the ratio of wins to losses was 9-4, and he won 72. And they want to know how many games did he play total. And that word is really important. Okay, so now let's get our double number line set up. First, go through your questions. What are we comparing? We're comparing wins to losses, and the ratio is 9-4. And he won 72 games, and I want to know the total games played. Okay, now let's do our number lines. Let's first write our labels. We have wins and we have losses. And we're going to make our number lines. Let me get rid of this for now. And let's see. Okay, let's line up our zeros. That's very important that we line up our zeros. And now, I know I'm going to count by nines for the wins. So I have to get up to 72. So that way I don't have to make any extra lines and I won't run out of space. So I'm going to count to myself 9, 18, 27, 36, 45, 54, 63, 72. And now I'm going to label 9, 18, 27, 36, 45, 54, 63, and again I can stop at 72 because that's in the problem how many he won. And then what am I going to count by on the L, or the loss number line? Well, that part of the ratio is 4, so I'm going to count by 4s. 4, 8, 12, 16, 20, 24, 28, 32. So let's see. Again, circle your 72 because he won 72 games. And what number goes with that? Well, 32, right? And if you think about it multiplicatively, 9 times 8 is 72. That's how many times I'm repeating the pattern. And 4 times 8 is 32. So he won 32 games. But is that the question? Let's go back. How many games did he play total? So how many games did he play? Well, if he won 72 and he lost 32, we would have to add those together. And so we get 4, and we get that he played 104. And that's how you would solve that problem. So remember, you can use the strategy, but always go back after you do all of your work. Go back and read the problem, because you don't get any credit for answering the wrong question. You could have all of your work. That's not true. You usually get partial credit on a problem. But you have to go back to avoid what we call question amnesia. Question amnesia is when you do all of this work to solve a problem, and then you forget what the original problem was asking. So again, in this case, they're asking how many total. So after you find the number of losses from your double number line, you have that extra step that tells you total. Well, the total is the wins plus the losses.